Welcome to clickmyproject.com. Let me discuss about the process dynamic cluster member scheduling for target tracking in sensor networks. Let me discuss about the abstract of the project. Clustering is one of the important methods for prolonging the network lifetime in wireless sensor networks. It involves grouping of sensor nodes into clusters and electing cluster heads for all the clusters. CHs collect the data from respective cluster nodes and forward the aggregated data to base station. A major challenge in WSN is to select appropriate cluster heads. Advances in wireless sensor network technology has providing the readiness of small and low-cost sensor nodes with aptitude of sensing various types of physical and environmental surroundings. This is based on standard election prospects of each node to become cluster head, conferring to the enduring energy in each node. Here proposed partially observable Markov decision process and propose a dynamic cluster member scheduling algorithm for solving the tracking performance and energy consumption. The selection of cluster head node by election method based on the optimal mixed weights of the signal strength and the residual energy of node. By performing dynamic cluster member scheduling algorithm, generate cluster members dynamically. This approach efficiently reduces the redundant nodes and lower the communication. Even though the cluster member is large, the target tracking need minimum number of cluster member nodes to transmit the sensor information, so that the cluster members are needed to perform sleeping or awakening scheduling model to save network resources and extend the lifetime of the network. Let me discuss about the flow diagram for our process. In this proposed work, high performance sensor nodes are deployed at the scope of the monitoring area. Low performance of sensor nodes are deployed at the rest of the monitoring area. At last, base station is deployed at the center of the monitoring area. In order to perform target tracking convergence, each monitor area is divided into several small areas. In each small area having few number of sensor nodes. These sensor nodes are formed as cluster, and cluster head is selected based on the node energy and signal strength. Here the election method based on weights are performed for cluster head selections. Low performance of nodes are treated as cluster member of the region. Each cluster members in the region is reported and transmitted the sensory data to cluster head of the region. CH is performed receiving and communicating with their cluster members. Finally, the CH receives, converges and sends the data to BS. Next, the cluster head choosing and switching model. Here, the selection based methods are adapted for performing cluster and cluster head selection process. In optimal, the cluster head selection considers the weights of the signal strength and the residual energy of the node, and the detecting signals of the POMDP algorithm of sensor nodes can be modeled as the state model is expressed as is the state model real location of the tracked data target and the state set of the residual energy of the sensor nodes, and state and transition function is represents probability that the tracked target moves to next positions. The observation function and transition models are performed. Finally, the action and reward model is also performed to finding the errors between the received residual energy and the residual energy of the action set. In the dynamic cluster target tracking, the cluster members sleep and awake or scheduling. Stage of establishing the cluster includes cluster head choosing and switching, cluster member scheduling and collaborating. Target enters into monitor area, starts the tracking process, and where the nodes involved in target tracking upload monitor area and energy to cluster head. If once the algorithm got converged and data has been sending, if the targets are tracked, then we perform the performance analysis. Otherwise, we once again perform the cluster head selection process. In the analysis button, the performance with metrics as target tracking accuracy by varying the number of nodes, calculation of network lifetime by various runtime, and tracking hour per unit time is estimated. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, write the file and run for executing this process. Here we perform the dynamic cluster member selection algorithm and we obtain the performance results. Here I will explain. This is the system model. Here the low performance nodes and also high performance nodes are deployed. At the center, base stations are deployed. And in the iteration, here we form the cluster formation in round 1, and the cluster head directly connected to base station, and each cluster member transmit the data to the respective cluster head. And this is the cluster formation in round 2. And here also cluster members and cluster heads are displayed and base stations are displayed. And this is the cluster formation in round 3. Here the cluster group and cluster base stations are performed. Each cluster head transmits their packets to base station, and every cluster members transmit their packets to cluster head. This is the cluster formation in round 4. This is the cluster formation in round 5. And here comparison of the target tracking accuracy by comparing existing method EC, DC and PPSS algorithm. And this is the comparison of the target tracking accuracy in different number of nodes. By varying the number of nodes, we calculated the target tracking accuracy and compare with our existing method DCMS, DC, EC and PPSS. This is the comparison of network lifetime. By varying the runtime, that is rounds, we compare the number of survival nodes and also compare with existing and our proposed system. This is the tracking error per unit time by varying the sensor awake per unit time. Trade performance between tracking performance and energy consumption. Here we compare with QMDP algorithm and also our proposed work. Demo completed. Thanks for listening.